Hello, we are here in the hydrogen laboratory of the HES-SO, and I'm showing here you our complete power-to-gas setup. The particularity is we have installed it in here in a chemical fume hood for safety reasons, in case hydrogen may escape. We are starting here with electrolyzer, which is directly powered from the solar panels on the roof of our school via DC bus, and the hydrogen and the oxygen which are generated are separated from the liquid in these two degassing systems. On the upper part you see the degassing system for hydrogen, and here the lower one, the larger one, is for the oxygen, because the oxygen part contains the water. For our proton exchange membrane electrolyzer we have to provide the deionized water on the oxygen side. And then afterwards, the oxygen we leave it out into the atmosphere, unfortunately, so far. And the hydrogen, we are drying it, and we can store it here, down there, in the red bottle in metal hydride system. The advantage is that the metal hydride system do not require very high pressure. We can work at about 6, 10 or 15 bar only. And you see the copper wire around it for cooling, because the hydrogen, when it's entering the metal hydride, it releases heat. Once the hydrogen is stored, we can use it, and we have two purposes for using it: either with a standard fuel cell, which is a commercial fuel cell stock with all the system around. This one has 2.5 kilowatt, which is about half of the power which we have used for the electrolyzer, which is approximately 5 kilowatt. And then the other option is that the hydrogen is used for conversion together with CO2 by a methanation reactor, which is in the backside. It's a little bit tight because we want to have the entire power-to-gas system within just one fume hood. We have a high temperature, 250-degree temperature methanation reactor, which is converting via the Sabatier process the hydrogen together with CO2 into natural gas. And then where does the CO2 come from? We are not extracting it from atmosphere because it's a very power-consuming process. We are using a bioreactor which is converting standard residues of a university canteen. We can fill it in here. It has a 20-liter volume. We can convert the residues from the food waste into biogas, which is leaving out here to the upper side, and then we have to dry it before we can store it here into a container. It's an intermediate storing system before we are compressing it to go to higher pressure into the methanation reactor. And this way we have succeeded to install the entire power-to-gas system into one little fume hood, which is approximately on the order of 2 to 5 kilowatt in total power. Thanks for your attention.